In this video, we're going to talk about graphing transformations. So whenever we talk about graphing transformations, we're essentially manipulating a function and its graph either by way of the x-axis or the y-axis. So let's start with vertical shifts, and let's talk about the vertical shift upward. So let's say that I have the graph of y equals x squared, which is a lovely quadratic, and let's say I want to transform that graph from x squared to x squared plus 3. So I'm adding 3 to that function. It is not manipulating the x because it's not right next to the x, so it's manipulating the y. So when you have like plus or minus a number at the end, that means that you're going to shift your graph up or down that number. It's pretty straightforward. So this one is going to shift up 3. You can make a table of values and just add 3 to every output, or you can take the points on x squared and just add 3 to each y value, keeping the x value the same. And so if we were to take that same function, x squared, and subtract 4 from it, again manipulating the y, not the x, I'm just going to take every y value and shift it down 4 from the original. So all of these, that 4, 0, and 4 will go down to be 0, negative 4, and 0, keeping the x value the same. So if we can shift along the y-axis, you can bet that we can shift along the x-axis. First, when I do anything with the x-axis, whether I'm shifting or stretching or compressing, which we'll get to in a moment, I am going to be manipulating my x variable or variables. So, for example, we started with x squared, and now I want x minus 2 all squared. See how that minus 2 is right next to the x? That means I'm going to be manipulating the x in some way. Also, what's important is that, well, at least the way that I think about it, is that if I'm going to manipulate the x mathematically, it's going to go the opposite of what my intuition would tell me. So remember when we did vertical shifts, we either added or subtracted, so we either went up or we went down. It's pretty straightforward. When I manipulate the x, it's backwards. So you might take a look at this and be like, okay, x minus 2, we go to the left, go negative 2, right? Wrong. We're going to actually go to the right 2 because the x, it's just backwards to at least our intuition. So that means that every point on my x squared function is going to shift to the right along the x-axis 2. So 0, 2, 2, 0, negative 2, 4, 0, 4, etc. And essentially the same idea is true for when we do a horizontal shift to the left. Again, manipulating my x variable, I've got a plus 4 in there. And again, remember, our intuition would be like, ooh, let's go to the right 4. But we have to go to the left because we're dealing with an x value transformation. So if I have our x squared here, that just means that this plus 4 will take every x coordinate and move it to the left 4. 0, 0 becomes negative 4, 0, etc. And what would it look like if we put together vertical and horizontal shifts, you ask? Well, let's look at this example. So I'm going to take my x squared function that I've been working with this whole video, and I'm going to add 3 to the x, square all that, and then subtract 5. You may now be wondering, well, which do I do first? Do I do the plus 3 or the minus 5 first? I personally like to take care of my x manipulations first, the things that are closest to the x, and then I work my way out. So inner to outer. That's personally how I like to do it. So this x plus 3 means that I will take all of my points on my x squared function and I will go to the left 3. So my 0, 0, for example, will become negative 3, 0. And then what I'll do is I'll take this new shape where I've shifted everything over to the left 3. That means that all of my points will now drop down 5. So 0, 0 becomes negative 3, 0, becomes negative 3, negative 5. So that's how you put those two things together. So we talked about shifts that essentially are addition and subtraction to our x or y values. But what happens when I multiply or divide instead of add or subtract? So let's first look at something called a vertical stretch. So let's move on from our lovely quadratic function and talk about a different one. Let's say our parent function is the absolute value function, and let's have 2 times the absolute value function. So the first thing that I like to think of is this an x or y manipulation? So the 2 is on the outside of our function, like our y. So that means that I'm multiplying my y values by 2. If the 2 was right next to the x, that would be an x manipulation. Remember, if it's right next to the x, we're manipulating it. So again, I'm not manipulating my x, I'm manipulating my y. So any of my x coordinates on my original graph are going to stay the same, but I'm going to double my output. So for example, let's say I want to look at -2, 2, right? Normally I'd plug in -2, take the absolute value, get 2. But with 2 times the absolute value, I plug in -2, get 2, and then I have to multiply that by 2. So 2 doubles. And that's going to happen to every output. So 2, 1, 0, etc. They double. 2 to 4, 1 to 2, 0 to 0, etc. So graphically what that looks like is that my absolute value function squishes inwards, which is definitely an Iannucci thing. So you can use it if you want. But that's what happens when I manipulate my graph using a number greater than 1. So what happens if I take my absolute value graph and then I multiply it by 1/2 instead of 2, or divide by 2 instead of multiplying by 2, however you want to think of it? Technically that's called a vertical compression, which compresses it down. And I'm going to do the same thing. So every output that I had on the last one I doubled, but I have a 1/2. So that means every output that I have, I'm going to cut it in half. So 2 becomes 1, 1 becomes 1/2, etc. So all of these points on our original graph drop down or compress. That's the mathematically correct term. So when you multiply a function on the outside, so we're manipulating the y values in our table of values or on our graph are the things that change. So now let's compare multiplying the y by a number like 2 or 1/2 and compare that to multiplying the x by a number. So let's switch things up and let's say this is my original function. This is a sinusoidal graph. You don't need to know that right now, but these 3 points are our anchor points we're going to manipulate. So let's say that I want to turn this f of x or this y function into 2 times that function. So the 2 is on the outside, meaning that I'm going to multiply my y values by 2. Because remember, manipulating the y, straightforward. So if it says 2 times y, you multiply every y by 2. So that's going to turn our y values of 1, 1, and -1 to 2, 2, -2, right? Pretty straightforward because all the x values stay the same. But let's say I have that same function, but I want to multiply the x by 3. So I'm not multiplying the y, I'm manipulating the x. And remember, even if you're adding, subtracting, multiplying, or dividing by x, you have to go against what your intuition would tell you. So intuition would tell me, okay, 3 times x, I multiply the x values by 3. Nope, you divide by 3. So if I'm just manipulating the x, 3 times x, that means that I'm going to cut each of these x values into thirds, essentially. So pi over 2 times 1 over 3 is pi over 6. 5 halves, 5 6. 3 halves, 1/2. But all the y values, 1, 1, -1, stay the same. Isn't it fun? So fun. The last type of transformation I want to talk about are reflections. Now, you can reflect about the x-axis and the y-axis. You can reflect over other functions, but we're going to keep it simple and just do the x and y-axes. So, if I want to reflect about the x-axis, I throw a negative in front of whatever function I'm looking to reflect. So, let's say I have x squared, And in order to reflect over the x-axis, I keep all of my x values the same, and I negate the y values. Because when you throw a negative in front of the function, you're negating the y values. So if you want to think of it like multiplying by a -1 on the outside of your original function, then so be it. And if you want to reflect about the y-axis, you throw that negative in front of the x. So whatever axis you want to reflect over, you throw the negative in front of the other variable. So that means that the square root of -x, which almost seems taboo, but it's not, I know, it's kind of crazy, is you take the original function of the square root of x and you make every x value negative while keeping the y values the same. So for example, 1 comma 1 becomes -1 comma 1. And here is a lovely summary, if you are a summary type of person, for the types of graphing techniques that we've covered so far. Either take a screenshot of this or find it in the textbook and paste that into your notes because it is so useful. All right, let's work through two different types of examples. In this first example, I want to write an equation based on a number of transformations. So let's say I start off with the parent function, y equals the absolute value of x, and I have these 3 steps to take in order to get the final function. So our goal here is to write a function, not graph it, just write it. So first up, shift left 2 units. So shifting left is along the x-axis, so that's going to manipulate the x. But remember, the x is backwards. So instead of going -2, we're going to do +2. So that's going to be the absolute value of x plus 2. And then second, shift up 3 units. So that's along the y-axis, which is straightforward, which we love. So that's going to be outside of this. So we're going to tack on the 3 to the end. Or you could do it in the beginning. I just prefer the end. So that's what step 2 is going to look like. And then the last step says reflect about the y-axis. So if I want to reflect over the y, I have to negate the x. And so this is my final function with these 3 transformations in mind. Now let's do one last example where we are going to graph transformations. So let's say I have this function, f of x is equal to the square root of 1 minus x plus 2. And then we'll find the domain and range. So the first thing that I like to do is identify my parent function, and that is the square root of x. And I love to look at the parent function graph along with 3 key points. So that's 0, 0, 1, 1, and 4, 2. So the tricky thing about this example is that my parent function is the positive x under here, but I have a negative. So I'm going to rewrite this function to see if I can't use my parent function a little bit easier. So in order for me to use my parent function graph, I need to have a positive x here, and I have a negative here. So I'm going to take out a negative, or I'm going to factor out a -1, so that leaves me with a positive x, but then that turns my positive 1 into a -1. And then obviously the plus 2 at the end. So I've got a couple of options as to what I want to manipulate first. I can either take care of this -1 or this -1. Fun that they're both the same. And then the last thing I'll do is deal with this plus 2. So let's take care of this one because it's first up. So if there's a -1 in front of my x, just like how it is here, that means that I need to reflect over the y-axis. So that means that my second step is going to be taking care of this -1, and remember, the x is backwards to our intuition, so instead of going to the left one, we're going to go to the right one. And then leaving the easiest one for last, or third, this plus 2 outside of the square root means that we're just going to shift everything up 2 on the y-axis. All right, so once I have all the steps in place, I'm going to take my 3 key points on my parent function and manipulate them in this order. So 0, 0, if I was to flip this over the y-axis, it stays 0, 0, because it's on both axes, just lovely. And then my second step would be to move 1 to the right. So I would be at 0, comma 1. And then when I move up 2, boom, boom, I'm at 1, comma 2. And so for my 1, comma 1 point, I'm going to first reflect it over the y-axis. So that means 1, comma 1 goes this way and becomes negative 1, comma 1. And then I move it 1 to the right. So that's 0, comma 1. And then up 2. So 0, comma 3. My third key point, 4, comma 2, going to do the same 3 steps because duh. First, going to reflect that over the y-axis. So it will become negative 4, comma 2, which is roughly there. And then I'm going to move it to the right one. So that's negative 3, comma 2. And then move that up 2. So negative 3, comma 4. And last but not least, we were asked to find the domain and range. So domain is going to be negative infinity up to 1, including 1. And then range is going to start at 2 on the y-axis and contain 2, and then go up to infinity. So there we go. So just one last plug here that the order in which you do your graph transformations doesn't really matter all that much. But this is the order that the book likes to take care of: reflections, compressions, and stretches, and then shifts. I like taking care of all your x manipulations and then your y. So you'll find a strategy that works for you, and then you'll be set. And that's going to do it for this video. Thanks for watching.